Flappy Bird is a fantastic game to get used to some important concepts in game development. So today we're going to remake Flappy Bird in Godot to get used to working with Godot. Now you'll want to go to the Godot website and just download the latest version. And then we're going to be working with the .NET version here. I'm going to be showing you all the code in C#, and the non.NET version doesn't support C#. If you want to also code with GD scripts, the .NET version still does support that. It just, if you want to also have C#, which is a nice thing to be able to do, the .NET of code editor, because you can't just use Godot's built-in editor, and frankly speaking, Godot's built-in text editor is a little clunky as it is. So what I use is Visual Studio Code, but anything that you like, just Visual Studio, there's Writer, there's Notepad++, whatever your preference is, you can use. As you start up Godot for the first time here, I already have a couple of projects, but we're just going to create a new project. I will call this Flappy Bird Tutorial. And there we can choose a renderer. Don't worry about that for now. You can put this in a certain location, wherever you want to have it on your... And you can choose a version control method. By default, it's going to say Git. You might as well leave it on Git, because if you want to add version control even later down the line, just having it set up for Git just from the start is nice to have. For now, again, one of those things that we're not going to worry about. We'll just create that new project. And if this is your first project with Godot, you might need to set up the link between Visual Studio Code and Godot. So we're going to go up here into Editor and then Editor Settings. And then if we scroll down, there will be a category called Text Editor. And we can choose an external one. So here we just set the file path to whatever the executable is for the text editor that we're going to be using. In my case, this is just the file path to my Visual Studio Code install. You'll also want to, in the case of Visual Studio Code, I think most text editors will be the same, include these extra flags. What that'll do is it'll allow you to open up that text editor at the exact file line and column when you have things like it throwing an error. Then you can just click on that error and it will open up the proper file and the proper lines of code that are causing said error. And we want to obviously then use external editor being on. Now that we have that out of the way, what we want to do is we want to start making our first scene. We don't have anything in here at all yet. And we're going to make a 2D scene because Flappy Bird is a 2D game. So we just add a new 2D scene and it just creates a blank new 2D scene. There's a handful of elements that we really want to take a look at here. Number one is the player. Obviously fairly important. Number two is spawning in the pipes that we're going to be dodging. Number three is going to be just having a nice little background. Let's start with the player because that's obviously the most important thing altogether here. So how does Godot work? Well, Godot works with a node system. Every single object in your game is going to be a node that has a certain responsibility for executing certain code. Be that player movement, be that player collision, be that a player inventory. All those generally would be on their own separate nodes that can be grouped together under a parent node that would be everything to do with the player. So let's get started with that. We can add a node with this little plus icon, gives us this nice little list of all the different nodes that we can add. And here we have effectively 3 or 4 basic different types of nodes. Number one is just node. This is a node that doesn't actually exist within the world. This is good for things like holding just data or functionality that doesn't really exist on a specific location, rotation, and scale within the world. Think about things like your inventory or maybe your character's health system or something like that. Then we have the node 3D and the node 2D, which are respectively nodes that have a physical location within your game world, either within a 3-dimensional world or a 2-dimensional world. Then we also have control nodes, and these are nodes that exist in your UI. Separate from your game world, just kind of rendered on top as a layer for just user interface type of stuff. Oftentimes what we'll end up doing is if we add a node that is purely for organizational purposes, it'll just be a normal, non-specific node. For now though, because we're going to be making a 2D character, we can look at all the subnodes, all the other types that are classified as 2D nodes, and see if any one of these works with what we're looking for. And And if we scroll down a little bit, I can't find it right now, but what we're looking for effectively is going to be called a rigid body 2D. Now there's two types of these. There's a character body 2D as well, which is a rigid body that is a little bit more specified to do stuff that is character-like. Think about moving, jumping, all that type of stuff. But Flappy Bird is actually so basic in the way that it works, we don't even need all that extra character-based functionality. All that we need a Flappy Bird to be able to do is move up and move down. And a rigid body 2D can do just that. A rigid body 2D is a node that will be able to handle collision and physics. And that's really all that we need for moving up, down, and colliding with the pipes. Let's create this rigid body 2D, and we'll call this our player for now. We'll get a warning here that says, hey, this node has no shape. I don't know what to do. And that's because the rigid body 2D expects to have a child node that tells it the shape of the collision that it's going to be using for all of its physics. We just right click on it, we add another child node. Now we can just add in a collision shape 2D to that. And you will see that it adds it as a child, so it adds it under the player's rigid body. Just the same way that the player was added as a child of the node 2D that is the root of our scene. It's the very first node in our scene. Everything is going to be attached to this node 2D. And in this case, for now, it's just the player. And then the player has a collision shape attached to it. This gives us another warning because this node actually needs in the details panel over here, the inspector, as it's called within Godot, to be given in a shape that it's going to use. So we can just click on this empty box here and it gives us a couple of standard values. In our case, we're going to be working with a circle shape 2D. If we select that and we zoom in, we can now see this is going to be the collider that we're going to be using with our rigid body. So this will be the collision for our player. However, this is kind of worthless because we can't see anything yet. Even if we play the game, first and foremost, is going to say that, hey, we don't have a standard scene set up in our project settings at all. Do you want the current scene to become our standard scene? And we're just going to say, yeah, that's probably a good idea. We'll need to save it and give it a name. So we'll call this main. It's a pretty standard name to call your very first standard scene that the game will boot up into. Usually this will be something like a main menu or something like that. We're only going to have one scene in this game that actually gets loaded in. So it doesn't matter that much in this case. Let's save it as main, and we'll see nothing actually happens, nothing is visible, it's only gray. And that's because we haven't given this thing anything to render yet. We don't have a sprite in it. So let's add in a new child node, and we can just add in a sprite 2D. It really is as simple as that. And now we need to give it in a texture that is going to be using to show us a visualization for this. I've taken the liberty to just go online and find a sprite sheet with all the assets that are used in Flappy Bird. I'll try to remember to leave a link to it below in the description so that you can download it as well. And I'm just going to drag that in from my other monitor just into Godot like this, and it will import it as a sprite file, or a texture file rather. Now it is good to keep organized, so we're going to make a new folder and we'll call that resources and put it in that folder so that we can just organize things a little bit better. With that image, we can just drag and drop that into our texture field here, and it's going to be rendering things, well, as that image now. But there's still a couple of issues. Number one, it's rendering the entire texture sheet. Don't want that. And number two, you can see it's a little bit blurry. We want this, because it is low resolution, to feel and look like pixel art, and not some type of blurry weirdness. The reason that it's rendering as blurry is because usually, when you have a texture and you upscale it a little bit, you zoom in on it, it's very helpful for things to get smoothed out a little bit, and it does that by blurring it. You don't want things to look too pixelated with things like textures 99% of the time. Pixel art being the exception. So what we can do there is we can come up into the texture settings here and set the filter to instead be nearest, and that's going to keep all of the sharp pixels, while also allowing us to scale this thing up to be a little bit bigger. So now how do we make a selection out of this sprite sheet? Because we don't want the entire thing to be our player character, do we? No, of course not. So if we come up back here into the sprite 2D, we can say, hey, we only want to use a region from this image. So we click on this and suddenly everything disappears. We can use these rectangle numbers to add it to region, or otherwise we can just click this Edit Region button, and that will allow us to, well, start slicing up what part of the image we use. We can set the snapping mode to one of a couple of different things. We can either make a grid that it will snap to in increments. We can make it snap exactly on a per pixel basis, which sometimes is useful, or we can say auto slice, and that is just going to find all of the individual sections of this entire image and just slice them up for you. So with that, we can say just we want to use this one, and then it just cuts out only that one. And for the pipes, what we're going to do is we're going to be, in a moment, picking the auto slice for this one and this one for the top and the bottom pipe. For now though, we have a player. It's quite something, isn't it? If we play the game now, we'll be able to see that we have a player that falls down on the edge of the screen. It's a start, but it's maybe still not entirely great. What we'll do is we'll first add a camera view to this so that we can actually say, hey, this is going to be the area of our world that we can properly see. And cameras are just nodes like everything else. So we can just type in camera, and we can add a camera 2D. That'll add this purple little rectangle here, and that's going to be the view of the game that we have. So that'll be centered on 0, 0, and you will see now if we play, it actually starts with our player in the center. Our player is still very small though, and we can do one of a couple of things about that. Either we can make the player bigger, but then we're also going to need to make the pipes bigger and the background bigger. Wouldn't it just be easier to say, hey, make the view of the world that we have smaller? Because then everything just stays proportionally the same to each other. Makes it a little bit easier. In the camera, we have this zoom. And if we just increase the zoom, you can see that the purple area that's going to be our little viewport here is going to start becoming smaller and smaller until we are at like 2.5, seems pretty good. And if we play now, we can see that the player is a lot bigger on screen. We can even offset the camera a little bit in the X by just clicking and dragging, and that will offset this such that the player is on the left side of the screen. Maybe just offset it by like 120, something like that, 140, something. You can play around a little bit with seeing what you like, and now it's all the way over there. We can even move it down a little bit so that the player starts higher up, and we're not moving the player in this case. The player is still at 0, 0, 0 position, or 0, 0, I suppose. We don't have a third axis. It's a two-dimensional game. We're just moving the camera view around to make it appear like the player is in a different starting position. And we're going to do something a little bit similar with the background scrolling in a moment, because our player is actually never going to move from this green line. Our player only will move up and down, never left to right. Everything else is going to be moving left to right or right to left. But before we can get to that, we still need the player to be able to actually do anything, because right now it just falls down and it's not really that great. Taking a real quick break here to say, if you're enjoying this or finding this helpful, a way that is entirely free for you to support me, if you don't want to sign up for the Patreon, is to go down below in the description to my Steam page for my own game and add it to your wishlist. Only takes a couple of seconds to do, but it actually does massively help me out and support me making my game and the content that comes along with it. So it becomes time to add our first script. We can click on any given node in our tree, and any node can hold one script. Again, these nodes are specifically made to handle one responsibility per node. In this case, this rigid body node that we call player has the responsibility of handling collision and handling physics. But we can add a script to that does all the stuff that it already does, and then adds a little bit of extra functionality on top. In our case, handling inputs and jumping. So if we come over here to the inspector panel with that node selected, we can say, hey, script, just click on this, and we can either load or quick load an existing script. But what we're going to do is we're going to be making a new script. Now, when you make a script, you can choose between GDScript, which is a Python-like scripting language. It's kind of nice in its own ways. I personally have a preference for C# for a number of different reasons that I don't really feel like are productive to really go in depth about. at least not in this video. We're going to be using C# for this tutorial. By and large, GDScript is seen as being a little bit easier, but I also don't think C# is that complex to get to work with, and functions more as a full-fledged programming language, which is really nice in a number of different ways. We can tell it what it inherits from, so this is going to say everything that this type of node or this type of script already has programmed into it. We're going to take all that stuff and add something on top. So our script will be able to do and access everything that a rigid body 2D otherwise also could. Give it a path and a name. Where are we going to be saving this? I'm actually going to save this in a new folder called scripts. And then generally it's also still nice to make a C# and a GDScript folder, because as we're using the .NET version, which allows C# programming, sometimes you still do want to just make something quick and easy in GDScript, and having a separation in your folders between where your C# scripts are and where your GDScripts are is just nice for organizational purposes. So let's just make a C# folder, and then we'll say we'll save it there. We create this, and that should open up our Visual Studio Code. Before we get started, I personally have the GD Tools plugin installed, which can be nice for things like being able to pull in things from a specific scene that you're working on. We're not going to worry too much about that, but it is a nice thing to have installed. You might need to, just like we selected the executable for the text editor within Godot, that plugin wants you to set the executable for Godot within Visual Studio Code as well. We're just going to kind of ignore that for the time being though. As are we Copilot, because I don't care about it. I will also zoom in a little bit so that you can read along a bit easier than having super tiny text on screen. And here we need to do a handful of things. Number one, we need to check if a player input was pressed. And then number two, we need to apply some force upward to send our character, well, up. There's two very important functions that most of your script will be using. The first one is called public override void underscore ready. This is the function, the bit of code that runs before anything else on this script. That is either when the game starts, or if you spawn these things in during gameplay, the moment they get spawned in. If you're used to things like Unreal Engine, this is the same as begin play. I forget what it is called in Unity, but if you've used the game engine before, you're familiar with the concept. The other one is public override void. And it says here that it's going to be called update. That is incorrect. Godot calls this process. And it takes in a parameter, I actually misspelled it, which is a double called delta. A double just being a number with the capability of having decimals to it. This is the function that will run every frame of your game. If your game runs at 100 frames per second, this code is going to be running 100 times within a second. If your game sucks and it only runs at 20 frames per second, this code is only going to run those 20 times per second. Things that need to happen every frame, such as checking for inputs, will happen in here. For the time being, if you don't understand this public override void section of declaring these functions, don't worry too much about them. This just means that other objects can see it. This means that the parent, so in this case the rigid body 2D, already has made this function, and we're just giving it new code to execute when this function is run. And this just says, hey, this function only executes code and doesn't actually deliver any data back to whatever called it. And then the stuff within these parentheses is the stuff that it's supposed to take in when you call the function. Obviously, we don't have any code that calls process, but under the hood, the engine will do that. We'll probably run into some more stuff that takes in parameters, or maybe even has return values as we go along here. And then this base._process delta is just saying, hey, run the base version, so the version that rigid body 2D itself has, whenever this version of the function, because it is an override, is run. If we remove this, it's going to not run all the code that rigid body 2D has within its process function. And generally, when you do something like this, you want to run whatever parent function also has in it. Sometimes you don't, but that is a very distinct choice that you make as you're programming. Now, the very first thing that we're going to do is we're going to write an if statement. So this is going to check for a certain something. In this case, what we're going to be checking is if our input dot is action just pressed. In the end, programming is very much just English. And that is going to take in a parameter of the name of the input that was just pressed. So how do we know what names we need to put in here or what we need to look out for? How do we decide these names? We do that by going back into our Godot project, going into our project settings, and then going into our input map tab. Here we can add in new input actions. So let's just add one that we call jump, press the add button, and then we can press this little plus button to add a mapped key to it. This can be a keyboard key, this can be a controller key. In our case, it's just going to be the spacebar button. You can just press it on your keyboard and it will automatically select it, which is quite nice. You can even make these only react to combinations with also Alt, Shift, Control, or Meta, which is the Windows, or maybe the Mac key. I don't use Mac. In our case, again, we're just going to go with space. We say apply, and there it says the physical space key is going to trigger the jump input action. Make sure we save that. Then going back into VS Code, this is just going to look for the name of the action that we made in our input map. So that would be jump. Now it's checking every frame if we just pressed any of the buttons associated with jump. We just assigned the spacebar to it, but we can assign multiple buttons to it if we wanted to. Then we make these two curly brackets, and that's going to contain the code that's going to run only if on this last frame our jump input was pressed. When that is the case, we will apply impulse, because that's going to give our rigid body a, well, physics impulse is going to give it a little bit of velocity into a direction that we supply in. So if we just hover over it, we can see it's supposed to take in a vector 2. A vector 2 is a type of data, a type of variable that has two numbers in it. One that has a value for the x and one that has a value for the y. So we need to figure out what are we going to put in here in the first place. For that, let's just make some code that figures out how we make that vector 2 and how we then give that a certain value. So we can just make a vector 2 variable just by writing out vector 2 and then giving it a name. So let's call this the impulse, just the impulse actually. Then we need to give this a value, and a vector 2 is a struct. So we need to make a new instance of this struct. Certain values, like maybe like an integer, you will see are colored blue in the default VS Code color layout. And those you can just, integer is just a number, you can just give them a value by typing in a value and you're kind of good to go. These green ones are structures, which means that they contain a couple of different bits of data, oftentimes also functions. They're a little bit more complex than these basic things like just being a number. So you need to make a new instance of them. So you just type in new vector2, tells it to make a new, well, vector 2. And then in the parentheses, you can give in the values for the x and the y component. So we can say for now that would be 0 and 0, for instance. This will make a new vector 2 and assign it to this variable so that we can use it. But we don't want to make a new vector 2 with just a value of 0 and 0 because that's going to do nothing. We want to make a vector 2 that has a value that will send our character up. For that, we need to ignore the x, because the x is the left to right direction. We want to give the y a value. We could just write something in here like 500, but oftentimes the kind of arbitrary magic numbers in your code are something you want to avoid because they're not super descriptive and they're going to be hard to change if you use them in multiple places. So what we will do instead is come up all the way to above ready, but still within the curly brackets that start and end this class, and we're going to be making a variable up here. This variable will be a float, which is similar to a double in that it is a number that has decimal values. A float is just slightly less accurate, but for what we're doing here, we don't need the insane accuracy that a double can give us. And this is going to be our jump power. And we'll set that equal to, let's say, 100. Now we have this as a variable that we can use. So we can say instead of saying 500 here, we can just write out jump power, and that's just kind of a stand-in to whatever value we put in here. So this is now worth 100. If we use this jump power in a couple of different locations, we only have to change it in one place right now. I'll do you even better. Godot supports making these things exposed to the editor windows so that you can actually change them just within the Godot editor if you wanted to. And to do that, you just type these little square brackets and you type in export within them. And you will see in a moment, once we go back into Godot, we then have a field that will be called jump power, which will have a default value of 100 that we can change. And then when we play the game, it will actually use the number that we gave in within the Godot editor. Really nice. There's one little quirk though that we need to talk about with these apply impulses in Godot, because you might think, well, jumping needs a positive value, the 100 that we gave in, but that's not quite how it works. Because Godot kind of works in the opposite way of what you would expect and what you probably have seen in other game engines as well. Because gravity takes you away from the world coordinate 0, 0, what it's saying is, well, that means that your velocity when you're falling is positive. So when we want to go back up and we want to go against gravity, we want to give in a negative impulse because that'll actually make us jump up. It's a little bit weird, but just remember, velocities in Godot assume positive number is gravity, negative number is counteracting gravity. So this vector, we don't actually want to give in the number for jump power because this is a positive number. We could just make this a negative number. But instead what we would do usually is just say, hey, take whatever value this variable has and just do the negative of that by just putting in a minus sign before it. Now this is going to read as negative 100. And then in apply impulse, finally, we just give in our new variable for impulse. At the end of every single line in C#, you add in a semicolon that just lets your code know that, hey, I'm done writing this bit of the code. A semicolon is just like a period in writing your normal like English or whatever language you speak. That says, hey, this is the end of a sentence. A semicolon is just the code version of the end of a sentence. This is one of the aspects that GDScript doesn't have. And it's one of the things that I personally don't like about GDScripts, because it is nice being able to see when a certain bit of code ends. Either way, when we've done all this, we can save this, which is quite important if your code editor doesn't autosave. When we go back into Godot, if this isn't saved, it's not going to have any newly updated stuff. So make sure that this is saved or you're using something that autosaves. Then I go back into Godot and you will see in a lot of places suddenly a warning. The inspector might be out of date, please build the C# project. That's because we changed something in a C# file and Godot can see that, but it doesn't have the updated C# code yet. So we go up here into this little hammer icon and we can just build. That's going to compile our C# code. And if there's any compiling errors, meaning that it couldn't compile because there's something wrong with the code, mind you, that doesn't check for bugs, that just checks for code that's written with, let's call it bad grammar. Things that don't make sense. A place where you missed a semicolon. Trying to use a variable that doesn't exist. That type of stuff. It will give you an error and you need to fix that error before you can move on. But as we can see, now that we are looking at the player, we have this jump power. Just as I promised we would have. If we play the game, make sure that you actually click on the game window. For demonstrational purposes, let's also set this gravity scale to like 0.1 so we don't fall as quickly. And then build or play the game. Make sure that you actually click on the game window, and then when we press the spacebar, you can see we start flapping up. We have our Flappy Bird, well, flapping. Now if we set this back to a value of 1, pretty good chance that all the flapping in the world isn't going to do that much because our jump power just isn't high enough. So you might need to play around with this a little bit, and that's why these exporting values can be kind of nice. Because we don't need to recompile our code every time we want to change a single value. Our code will just know that whatever value we put in here is going to be our jump power. So with 500, hopefully this will be good. Again, make sure that we actually have clicked on the little game window here, because if we click off of it, we won't have focus on the game window and our inputs will be ignored. It's a little bit of an annoying thing that Godot sometimes has. But 500 might be enough. Maybe it's even a little too much. Maybe 400 is a little bit better. So we just check this. 400 seems a bit better. If you don't like the amount of gravity that we have, we of course can still just decrease the gravity scale a little bit so we fall a little bit slower. We'll also need to decrease our jump power accordingly though. And just like that, you can start tweaking how your game feels a little bit like this. Flappy Bird isn't fun if we don't also have things to actually, well, flap through. We want the pipes. So let's make some pipes. What do pipes need to do? Well, they need to move through the screen and they need to restart the game when we collide with them. And this is where we start going into instancing different scenes into each other. Because we actually have two different things, or potentially three different things, that need to restart the game when we hit them. Because when we hit either the top of the screen or the bottom of the screen, we also want to end the game and restart. So we want to make an object that's going to be able to be used in all those different types of context. So let's get started with making that. We can add a child node just to our scene, and that's going to be an area 2D. This is just a collision that's not going to be colliding in the same way a rigid body would. Rigid bodies would stop you moving through walls, that type of stuff. These area collisions are more so for checking things like overlaps. Is your character within a certain area of the world? So in this case, we're going to be using this as a kill zone. This also wants a collision shape, but we're actually not going to give it one quite yet, and I will show you why in a moment. What we will do is we will go ahead and add a script to this as well. So a new script, be C#. We're going to put that into our scripts C# folder, and we'll call this killzone.cs for C#. Create that. And here we start looking into events. In GDScript, they'd be called signals. We're using C#, so we call them events. An event is a special type of variable that is able to just give out a signal, which is why Godot calls them signals, when something happens. The area 2D has a pre-made event that will just signal whenever something overlaps with it. So we want to make some code that will actually map into that event. The way that we do that is by first setting that up in our ready function. So public override void underscore ready. Just run the base ready, that is fine. And then because this is a script that works off of the area 2D, we have access to everything that the area 2D has programmed into it. So we can start typing body entered. And in this case, I don't know if different IDEs will have different icons, but in VS Code, they will be shaped like little lightning bolts. These are events. In this case, we're going to go for body entered because we're looking for whenever a rigid body, in this case, enters this area 2D. Whenever that happens, we can say plus equals. That's going to be adding whatever function we give it in after this plus equals to be run whenever this body entered is signaled to run. We can just start writing out something here. So let's say handle player overlap and add a semicolon. It's going to give you an error, but if you have a decent code editor, you can just usually like hover over this and it will give you a fix, generate the method handle player overlap for us. That's going to give us the function that's going to run in response to this. If your IDE doesn't do that, what you would need to do is you would need to know the parameter that this specific event is supposed to take in, which can be a little annoying. That's where things like looking at the Godot documentation can come in handy. You would need to look this up on the website, see, okay, what type of function is supposed to run in response to this event, because it is quite important that it has the proper parameter. This needs to be a function that takes in a node 2D for this to work. We'll see if I change this into a float, just call it number or something like that. This is going to start complaining at me because I'm trying to attach a function that doesn't match the type of function this event is expecting. So having a nice code editor to just be able to make it generate that for you and not need to worry about that can be really helpful. Now by default, this included a throw new not implemented exception because, well, we haven't implemented anything in it yet. So how about we fix that? We write in some code. When we overlap with the player, we want to do a couple of different things. First, we want to check, hey, is this actually the player? Is this something else entirely? And there's a number of ways that we can do that. The easiest way to do that is to check if whatever we're overlapping with, so our body, that's going to be the value that's given in. This is a reference to whatever object just started overlapping, just entered this area. So we can check if that body is a player script. And that's just going to check, hey, that node, does it have a player script, which is the script that we made right here, on it or not? If it does, we can actually assign this as a variable called player, and it will run whatever we put into these brackets. If the body that we're entering here does not have a player script on it, it's just going to skip over everything within these brackets. So this does two things. It checks for us, is it a player? And number two, if we don't actually need to use any code specific to the player script, we now can because we have a variable of the type that will allow us to do that. But for now, we don't actually need to do any such thing because we're going to keep it super simple. All that we're going to do is we're going to just reload the current scene. And we can do that very easily in Godot by typing get tree and then brackets because that's a function. And then we can type dot reload current scene. And that just reloads whatever scene is currently active. Now we have a reusable little kill zone that we can use in a bunch of different places. So let's put that to the test. We'll go back into Godot. We'll build the code that we just made. And if we give this, even if just temporarily, the area 2D is going to have a shape 2D in it as well. Let's give this a rectangular shape. And then just put this at the bottom of our screen for now. And this is going to, because it has this script, which itself is going to just handle reloading everything the moment the player overlaps with it, we effectively have our very basic kill zone. In a full game, you would set this up a little bit less hard-coded. You'd have systems that would reload the game. It would pop up like a respawn menu, that type of stuff. We're not going to do that here, but we can run this and we should be able to see that this indeed just over and over and over again is going to restart our scene. So we have our basic kill volume. The reason that we didn't add in this collision shape right away though, is because we're going to right click on this thing and we're going to say we want to save this branch. So that's this node and every node that is attached to it as a scene. And we'll call this kill zone. And we'll make a new folder for this as well. And we'll call this scenes. Now, the weird thing about this engine is that these scenes can work as, well, scenes that we can just open. But they also immediately work as a prefabbing system. So we can just drag in the scene that we just made a whole bunch of time into this tree. We'll be adding a whole bunch of kill zones. And every instance that we just dragged in can have its own area collision shape assigned to it, just like this. So we can make a kill zone now that is circular shaped. And then this one can be, if we add in another collision shape 2D, maybe capsule shaped. And then this one can be rectangular shaped, and so on and so forth. In effect, what it is doing is if we double click this scene, we can just open up just the kill zone scene. It's the same way as adding a child node inside of this. So giving a child node that this area 2D requires within here, we can just do that on a per instance basis super easily within other scenes now, which is really cool. So again, we're going to be dragging in a kill zone and we'll make that kill zone have our collision 2D shape. It's going to be a rectangular shape. And we'll just kind of put this down at the bottom of our world. The fun bit is we don't actually need it to go all the way through to the end of the screen because we're never going to be moving left or right. So just having the kill zone here would be enough, but might as well, right? So we put this at the very bottom of the screen and then we can just copy this one over and we can pull this one up. If you hold down shift while moving something, it will only move in either the X or the Y axis, which is really nice. And make sure that if we go off the top of the screen, we also, well, die. Now you notice something annoying here, and that is because I pasted it while still having the area 2D selected. It is now attached to the previous area 2D. In this case, that's not too bad. Nothing terrible will happen because of that, but sometimes that can be annoying. You can just kind of drag this onto the root of the scene again, and now they're entirely separated again. So now we will see that if I fall all the way down, the game restarts, but if I go way too far up, the game also restarts. So we need to stay within the bounds of the screen. And just as easily as that, we can now start making the pipes. We're almost done making the actual Flappy Bird part of this game. From there on, there's a whole bunch of stuff that we can do, adding the background and animating our character a little bit more, but that's beyond the scope of what we're doing here today. So let's add a child node to the root of our tree here. And this time we're going to make a sprite as the very first thing we add. So just like we did before, we just drag in the sprite into here. We say, hey, we only want to use a region, edit that region, auto slice it, and we're going to be saying we want to use the top pipe for this one. And then I just copy this one over, make sure it's pasted, and I'm just going to keep this as being attached to the first sprite. I will call this one the top pipe, and then I will call this one the bottom pipe, and move this bottom pipe down a little bit by just dragging it down and saying I want this to display a different region. I want this to be, well, the bottom pipe. Then we're once again going to make a scene out of this, and instead of doing right click and save branch as scene, which is possible to do, you can also just kind of click and drag this into your file system here, and it will just make a scene for you. So let's just call this pipe scene, and this is the exact same thing, it's just a little bit quicker and easier to do it this way. If you want to open up any scene that is nested within a scene that you're editing, you have this little movie icon here, and that opens this scene in the editor. Now what I actually want to do is where these two things cross, these two lines, that is the 0, 0 position within this scene. And that's going to be the anchor, that's going to be the origin point of whenever we spawn this into a different scene. So as you can see, if I say, hey, this pipe, let's remove it from this tree for now. If I drag it into this scene now, you can see that its origin point, where it got spawned in, is right here. Which is a little annoying because for these pipes, you probably want the center point to actually be between the two pipes, right? So what I'll do is I will take this and just move it up a little bit until it is above this red line. And I'll take this one and move it down until it's a little bit below the red line. This isn't super specific, but it's just nice that the actual center point is, well, in the center. It might give you a little bit of an error when you do this because usually the roots of any given scene shouldn't be transformed. In this case, it doesn't really hurt that much to do it, but if you're really worried about it, what you can just do is you can add in a new node 2D and say, hey, I want this one to be the new scene root. And then this is going to be the new scene root, and then these two can be safely just moved around and transformed instead. Now, if we go back into the main scene, we will see that the actual center point of this instance scene is indeed something that's a little bit more workable and how we would expect it to be. It's this little red dot that we see here. We also need to not forget to go into its texture settings within the actual scene that we have here and set these to nearest as well, because otherwise they're going to be blurry, and we don't want these to be blurry. Texture, filter, nearest, just like that. And now we can zoom in and they remain sharp. At this point, we just need to add in the kill zones to these pipes. So what we do is we take the kill zone and attach it to the top pipe, and a kill zone and attach it to the bottom pipe. And on both of these, all they need is to get a child node, which will be a collision shape 2D. And for the top pipe, they're both going to be rectangles as well, of course. For the bottom pipe is the one that we're doing first. We just drag it up a little bit to make it as big as the pipe that we're working with. And then we add in one for the top pipe as well. Child node, collision shape, create, make it a rectangle, and make it as big as the pipe that it represents. And because this is the kill zone scene, that we're giving a collision shape to. We don't need to specifically program anything in these pipes that's going to kill the player and restart the game and whatever, because the kill zones already have the scripts on them that does that. All that this pipe needs to do at this point is just to move itself from right to left, and then when it is at a certain point, delete itself. So let's give it a script to do that. We can just come up into the very top here of this pipe scene, and again, just give it a script, add a new script. We'll call that pipe, that's fine. I want to add that into my C# folder, keep things organized. And here we just need to use our public override void underscore process, because we want every frame to move this pipe a little bit to the left. So for that, we're going to need to set its position, which is just a value that we can directly set. And we're going to be subtracting from that. So you can do minus equals, similar to in the kill zone, how we did plus equals. All that this does is saying, hey, whatever your current value is, plus this, which might not be super intuitive for a thing like an event, but events are more or less just a list of functions that need to run in a response to whenever that event happens. In this case, our position is a vector2. It's a x and a y position. So we can just say, hey, this position, whatever you are, minus equals. So just subtract whatever we put in here from the current value. Once again, here we do a new vector2, and we're going to be subtracting some amount, let's say 1 for now, in the x and nothing in the y. We'll do the exact same thing as we did before, making this a variable up top. So we'll make these square brackets, set this to be export, and then we'll make this a float, and we'll call that something like move speed. And then we'll say this vector2 is going to just be our move speed and 0. There's an issue with this though, because as you recall, this will run as many times as your game has frames. If you have 300 FPS, that means that this is going to move the move speed amount, which we can give a default value if we want. Let's just say 100. So 100 units to the left every frame. At 300 frames, that's very fast. At 30 frames, that's a little less fast. So we need to make something happen to this value such that it is always going to move the same speed no matter the frame rate. And that's where this delta comes in. Delta is the time that it took to render and process the last frame. So if we take whatever value we have, let's say 100, because that's what we're using here, and we multiply it by the duration of however long that frame took, we get a value that we can use to move around things and change things in this process function that's going to then behave pretty much independently from however high or low your frame rate is. So let's make a float actual speed and set that equal to our move speed multiplied by your delta. I was going to scream at you here because it doesn't like it when floats and doubles interact like this, because it kind of gets freaked out. There's one thing that we can do, and that is change this into a double, but then this is going to be annoying because a vector2 expects in a float and not a double, and it's just a whole bunch of annoyance. And a float and a delta are very similar types of information. They're both numbers with decimals, it's just a double is a lot more accurate. It's kind of hard to tell a float to act as a double because it needs to suddenly gain accuracy that it didn't have before. But we can very much say, hey, you double, stop being so annoying and being so accurate, just pretend like you're a float. And the way that we do that is just to, before the value, put 2 parentheses and tell it the type that is going to be pretending to be is going to be a float. So now it will use this double as if it is a float, and it stops complaining at us. So we can use this actual speed in the position, and now it's going to say our position for this pipe is going to be subtracted by our actual speed in the x and nothing in the y. And with that, we're almost there, because now we have a pipe that will move from left to right and kill us if we collide with it. So let's put this thing just somewhere over here. I have no idea how fast 100 is, so we're going to find out super soon altogether. There we go. And there we go. If I run into it, it resets the game. How do we make this thing spawn in over and over again? For that, we're going to make one more thing, and we're going to call that a pipe spawner. So let's make one more child node, which is going to be a node 2D, and we'll call this pipe spawner. We'll add a script to it. We make a new script. Again, I want to make sure that it's in the C# folder, and we'll create it. Now, this pipe spawner is going to need a handful of things. It's going to need a timer, which we'll need to add in Godot in a moment. And it's going to need to know which scene to spawn in that is going to be the pipe scene. So for that, make an export variable, and that'll be of type packed scene. This is a variable type that's just going to allow us to put in any scene of the game. And with that packed scene, we can just say, hey, make an instance of this. Spawn in this packed scene into the currently active game world. So we'll just call that packed scene. That is fine. And since we want to be able to spawn this either up or down by a certain amount so that they don't always spawn at the exact same height, because that would make the game kind of boring, we'll add another export with a float, and we'll call that something like height. We'll make a private void spawn pipe function. We mark this as private because it doesn't need to be public. No other objects need to be able to call this, and we don't want to accidentally allow other scripts and other people working on the game to call this when they really shouldn't be messing with this. So sometimes you want things to be public because other things need to be able to access it and to run it or to get data from it. If something is just internal to only this script itself and no other object needs to be able to interact with it, we mark it as private. And here we make a new node 2D. And this is not a new node 2D, I should point out. This is a variable that's going to reference to a node 2D that exists in our game world, in our tree hierarchy. So we'll call this new node. And that's going to equal our packed scene dot instantiate. Now you can do a funny little thing here, and this is one of those things where again C# is really quite handy. We can give in a type that is going to instantiate as. So we can actually just say that we want to instantiate this as a pipe type variable. And then of course this node2D type needs to be a pipe. But if we do that, it's going to instantiate this and immediately allow us to make the new variable that we've just created of the proper type so that we can do our pipe related stuff with it. It's kind of neat, but that's only important if you want to access any code that exists on your pipe scripts, and for the most part here we don't. So it's good practice to keep your variables as generic as possible until the very moment that you need them to be specific. We don't need to do anything specifically pipe related here. All that we need to do is to spawn this thing in and offset it a little bit up and a little bit down. A node2D allows us to do all of that, so we only really need this to be a node2D type variable. It's still going to spawn in a pipe, it's just this script isn't going to know that it is a pipe. We do need to tell it that it's going to be a node2D still though. Then we create a float within this function, and we'll call that offset. And that is going to be equal to our height, either in the positive or the negative or anything in between it. So we need to get a random number within that range. We can do that with a built-in library called GD for Godot, and that has the randRange function, which is going to give us a value from negative height to positive height. Now this will also be an annoying little thing because it's going to try to give you a double because it wants to be super accurate. We don't need this to be a double, so we just put in, hey, whatever you put out here, pretend to be a float so that we could put it into this float variable. Then it is time to add this to the scene because we've instantiated this node, but it doesn't actually exist yet in our tree. And this is sometimes pretty useful because what this allows us to do is create the node, do some more code to it before it gets added to the screen and runs its own ready function. Sometimes you want to set up its initial values differently through code or whatever. So we can do whatever we want here before we actually add it to the screen. In this case, we don't need to do any such thing. Now, very often when you spawn in a new node, you will probably be spawning it in as attached to whatever script is doing the spawning. In which case you would just do add child and we'll just add the new node here. In our case, what we actually probably want to do is we want to add these to the root of our scene. And the reason for that is because if we do it that way, it's going to be a lot easier for us to automatically destroy these pipes once they are off screen. And I'll show you why in a moment. But the way that we do that is we can just get the tree, which is the entire like game tree, which more or less just gets you the very topmost node of the entire game running. So we can get that current scene from it, .current scene, .add child. And now it's going to add it to the root of our current scene instead of directly to our pipe spawner node. Now that we've done that, we can get our new node again, and we can say its position is going to be plus equals a new vector 2. In the x, we're going to add nothing to it, and then in the y, we're going to be adding our offsets and then ending off with a semicolon. So we create a new node, we calculate a offset, which we don't need to necessarily do that there, we can just do that there. It makes a bit more sense to read through. We actually add it into our game. We can do all sorts of things in between there if we need to. In this case, we don't. Then we generate a random value for an offset, and then we just offset our newly spawned in node by that amount, either up or down. Now, this spawn pipe is going to need to run on a loop. It's going to need to spawn a pipe, let's say, every second or so. And for that, let's set this up in public override void underscore ready. Here we need to get a timer and then tell that timer that, hey, whenever you run out of time, run this spawn pipe function. So first we'll get a timer, just call that timer for now. And we'll say that that is equal to get node of type timer. And then we need to give in the name or the path to that node within the scene that we're working with here. This is a kind of hard-coded way to reference two other nodes within your scene structure. So if we go back into Godot real quick, and we get our pipe spawner here, we can add in a child node, and we'll add in the timer. Make sure that it's attached to our pipe spawner. And what this is going to look at is it's going to try to find, starting at the node that has the script attached to it, for the exact file path, just the same as you would be used to in something like your Windows Explorer, that we give into it. So in this case, because there's no like super deep nested stuff, the actual name that we're looking for is just timer. But just to make sure that we understand, it's not about the fact that this is a timer. So let's give this a different name. Let's call this spawner countdown, something like that. Then in our code, what we're going to be looking for will be, in quotations, that exact with capitalization. So don't mistype it like I did. And don't forget what you called it, spawner countdown. Countdown. And this will try to find a node with this exact name. If it is within another node, so what you can have quite often actually, is having other nodes that are attached to nodes within a tree view. We have a lot of this nesting going on. You would need to first specify the node 2D, and then slash, and then the name of the actual node that we're looking for. Do pay in mind that if this path specifically exactly doesn't exist, this is going to fail, and this value is going to be invalid. So this is kind of a tricky way of doing that, but it is a way that you can do it with getNode. It's a way that you're going to be seeing a lot when you're working with GD scripts, because GD scripts allows you to drag and drop these in a little bit easier. If you have the GD tools plugin, it, I believe, also allows you to drag and drop a currently open scene in to get this get node with the proper path to that node. This is one way of doing it. It's good to be aware of. What we're going to do actually is we're going to just make this as another exported variable, because that's just a little bit of a safer way to do it. And I'll show you how that works in a moment. Then we always, with this type of stuff, we check if our timer, and we want to check the actual variable, not the type, is not equal to null. And this just checks, hey, is this actually a valid timer did we assign anything to this variable or not? Because if we didn't, it's going to crash and give us errors and all that kind of stuff, and we don't want that. So we just then take our timer.timeout, and we add to that our spawn pipe. And now every time the timer times out, it's going to run spawn pipe. We also, just to be sure, can add a else. So if our timer actually is not valid, we can say gd print, and then we can just print an error message like error timer not valid in pipe spawner. And that'll give us something as feedback if this ends up not working. So if we go back into Godot and we build that real quick, I'm going to remove that node 2D because we don't actually need it. That's just for demonstrational purposes. So let's delete that. Select our pipe spawner, and we will see that we can assign first and foremost a height, let's say 30 units up or down. We can tell it which scene to spawn in, so we can quick load, and it's just going to give us a list of all the scenes in our project. Of course, we're going to want to spawn in the pipe. And then the timer, we can just pick from all the timers that we have in this scene, which is going to be the one timer that we have. Now we do need to set up that timer because by default it's going to not automatically start. Timers can be one shot, which means that they don't loop. We want this one to loop, so don't make it one shot. We want this to auto start, and then we can tell it how long between timer loops it's going to take. 1 second seems pretty good. Now this pipe spawner is still at 0, 0, 0. So if we just grab this and move this along a little bit like this, we'll probably want this to be roughly in the middle of our screen here, and then just move it ever so slightly off screen. Also delete this one pipe that we have. And with that, it's going to now, if everything works properly, start spawning in these pipes. Now it is spawning them in at 0, 0. Which makes sense because we're adding them to the current scene's routes. So before we add in our offsets, what we want to do is we want to set our new node's position to be equal to our spawner's position. Things as easy as that are sometimes easy to overlook. But now that we have that fixed, we should be able to see that it starts spawning in a lot of these pipes. And they're a little like too tied to each other, and they're definitely too difficult to maneuver between. So there's a little tweaking that you can do to make this game a little bit more fun and just a little less frustrating in general. One last thing though is these pipes are never going to disappear. And the reason that we added them to the scene routes instead of adding them as attached to the spawner, like you would probably usually do with most objects, is because that way we can easily check their position. And if their position is beyond a certain amount to the left, we can just say, hey, delete this pipe. So this pipe is going to, in its process, also then check if our position.x, so that's the left to right value, is less than, let's say, -500. That means that it is well off screen. Then we just say, hey, we can queue free. And queue free just tells the engine that this node is ready to be deleted. It will be deleted at the end of this frame. So it will still exist for the duration of this frame. Oftentimes it is safe to still write some code that happens after queue free because it's not immediately deleted. It is good practice to try to not rely on executing code after you've set something to be queued free, but generally it should be safe to do. And from there we have a functional, albeit in desperate need of balancing, game of Flappy Bird. Now with a little bit of extra work adding in the background and doing a little bit of extra touching up, balancing the stuff, I've added a score counter in this version as well. This video has gone on long enough, I don't want to drag this on any more than it has, but this is the version that I made as a reference for this project before getting started. And as you can see, the code for this version is almost identical to the version that we made, just with a couple of extra little bits added to it. It's a little bit more zoomed in, things are a little bit slower, and just generally maybe also a bit too easy in this version. but this is Flappy Bird, and now you have made it too. Now, that said, if you want the project files for the version that we made in this tutorial, they will be below in the description for YouTube members and patrons. It helps support this type of channel, especially since I'm trying to branch out a little bit and experiment with making some Godot videos. Help support me quite a lot, and you get access to the full code that we made here. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. My Cave student tier supporters, Oiku, Earl, Monserville Erno, and my Cave digger tier supporters, Mauricio Farias and Chang the Dude.